Okay. Hello, everyone. Good evening, good afternoon, good morning, wherever you are on this planet. Welcome to our Weizenbaum-Forum on cybersecurity governance challenges in times of growing geopolitical tensions. My name is Volker. I head the research group Digital Economy, Internet Ecosystem, and Internet Policy at the Weizenbaum-Institut, and I have the great pleasure and honor of moderating today's discussion. Thank you all very much for joining us for today's event, and a very special thank you to Cecilia Testart for co-organizing this with me and our stellar group of panelists for being here. Thank you, folks. Now, you may ask, why did we come up with this topic in the first place? So let me walk you through some of these thoughts and give you some context. Our societies and economies have become deeply and in many ways irreversibly dependent on digital technologies, directly and indirectly, with or without awareness. A broadening variety of networkable devices is deployed across homes, workplaces, industrial environments, and almost everyone, right? And everything is always on, interconnected, and computing, and increasingly AI assisted. As these technologies become more pervasively embedded in private and also professional environments, of course, threat landscapes evolve, and cybersecurity risks at the infrastructure, device, product levels are arguably becoming harder to manage. And there are a bunch of, as economists would call, externality, asymmetric information problems at work, which, for example, Anna Maria, who is a panelist today, and I examine in detail in our joint work. So while policies to address cybersecurity and resilience have emerged, we see geopolitical tensions that complicate a harmonized path forward. Now, let me briefly walk you through the landscape. Now, behind platforms, networks, devices, I just mentioned, right, and more broadly behind service provision in today's digital economy, lies a complex and evolving fabric of interconnected and complementary resources. Network computing, from hyperscale data centers to edge locations, communications networks from fiber and 5G to submarine sea cables, software, which includes all kinds of machine learning, AI-related stuff, and data of all kinds. Now, these resources are organized into overlapping multi-layered stacks. Many of you have heard the term AI stack, and also probably how these stacks are controlled by large tech companies. Now, make no mistake, we have witnessed over the last 2 decades or so a seismic shift in the way the internet is interconnected, where servers are positioned, data is stored and processed, and how and from where content and application services are distributed and delivered. Think on-premise, think edge, think cloud, all kinds of stuff. Well, before the recent hype around AI, leading tech firms were building highly scalable, extensible infrastructure substrates that underpin a growing share of economic activity. Now here, again, more recently, AI has driven massive investments in these stacks. And if you include to the picture stuff like softwarization and modularization, we see expanding options for seamlessly combining these resources. Now, the result is that value chains are becoming more fluid, ownership and control structures are changing, and competitive dynamics are being redrawn. Now, here's a critical point for our discussion today. These AI-driven ecosystems are characterized by a fabric, a complex and evolving fabric of technical and business relationships, and a variety of dependencies and interdependencies that are often opaque and poorly understood, even by the stakeholders involved. Now, add to this that the underlying resources are owned and managed by different, very often competing entities with imperfectly aligned incentives and varying capabilities to secure them, report incidents, and collaborate. And you begin to see, I guess, why the security landscape and the cybersecurity threat models are growing ever more complex. Now, the consequences are tangible. You probably have heard of outages at major cloud platforms that have shown how a single point of failure can cascade across entire sectors. So dependencies can give rise to more systemic risks or harm. Now, the deepening interdependencies between compute data and AI model supply chains, for example, now in the case of AI models, combined with growing geopolitical tensions, heightens concerns around cybersecurity, resilience, and digital sovereignty. Now let's shift gears a bit and look at networks. At the network level, Core internet protocols, such as the Border Gateway Protocol, BGP, were not originally designed with security in mind, leaving them susceptible to misconfigurations, deliberate attacks, such as route hijacking. While the resource public key infrastructure, RPKI, for example, offers a cryptographic framework to address some of these vulnerabilities, adoption remains a challenge. I'm sure that we will hear more about this from Cecilia later. Now, this is also, this kind of network vulnerabilities and resilience, if I may add, is also an area where Cecilia and I, along with David Clark and Bill Leary, have explored the internet resilience topic in a joint paper 2 years ago. Now, when we switch focus to the device level and product level, we see an explosive growth of the Internet of Things, the IoT, which has introduced billions of connected products into homes and workplaces, many lacking basic security features. Now, when you think about the security context, traditional perimeter-based security models are increasingly invalid here. A compromised IoT device can act as an internal adversary, enabling lateral movement within a network, replay attacks, long-term surveillance, and so on. Risks especially pronounced in consumer environments without professional security oversight. Now, AI and large language models and so on are now being integrated directly into these devices, while many routinely communicate with servers across multiple jurisdictions in ways often opaque to users and regulators. We have seen that in the EU, the Cyber Resilience Act represents an important policy effort to address some of these issues. And here, of course, I think Anna Maria will talk a bit about this later, and we have also current research collaborations on these topics. Now, having briefly mapped and walked you through this landscape, let me turn to two forces, like cross-cutting forces, that further complicate the picture. I will come back to AI itself. So AI is in a way a double-edged sword. While it can enhance threat detection and cyber defense, it may also be leveraged to launch more sophisticated attacks and identify vulnerabilities at unprecedented speed and scale. AI is also becoming deeply embedded in network operations, from traffic management to automated routing decisions, raising questions of whether this enhances resilience or introduces new risks. As of now, it seems far from clear whether jurisdictions are converging or diverging in how they approach these challenges. Second is geopolitics. I mentioned this before. Coordinated international responses are becoming increasingly difficult precisely when they seem most needed. The EU, for example, finds itself navigating aspirations for strategic autonomy and the realities of a deeply interconnected global digital economy. Questions of how to balance sovereignty, competitiveness, cybersecurity require addressing complex trade-offs. Now, these dynamics and complexities bring us to the questions that will guide our discussion today, and I should note that they run in both directions. On the one hand, where do cybersecurity challenges touch on geopolitical and sovereignty concerns? How is the integration of AI into devices, networks, and critical systems changing the threat landscape? Are we seeing fundamentally new attack surfaces or an amplification of existing problems? And what should governments care most about when it comes to centralized control, dependencies, and systemic risks? On the other hand, where do geopolitical and sovereignty dynamics reshape technical cybersecurity questions? How are governments recalibrating the trade-offs between openness, efficiency, and security? Now, and what are the implications of cross-border data flows and concentrated control over critical infrastructure for the enforceability of regulation? Now, these are huge challenges, and we couldn't be more fortunate, right, to have a truly outstanding and interdisciplinary panel with us today here, bringing together expertise from diverse geographic and institutional contexts. Anna Maria Mandalari is a lecturer at University College London and co-founder and CTO of Moulini. Anna Maria is a leading expert on IoT privacy and security and a member of the Italian Technical Secretariat of the Committee for Strategies on the Use of AI, among other things. Anna Maria, please apologize that I cannot read all the affiliations you have and all the awards and stuff. But as I mentioned, so Anna Maria and I have collaborated on the analysis of the European Cyber Resilience Act, and she brings invaluable technical depth and a strong European policy perspective to our discussion.
Thank you. Good evening, and thank you for the invitation. And as Volker mentioned in the intro, today we'd like to focus on a dimension of cybersecurity governance that is often underestimated in geopolitical discussions, that is the security and privacy of connected devices, what we call the Internet of Things. And usually when we talk about the cyber threats in terms of geopolitical tension, we tend to think about cloud infrastructure, AI models, undersea cables, large-scale critical infrastructure, and outages at AWS, Cloudflare remind us how fragile centralized digital infrastructure can be. But behind these visible layers lies a quieter, massively distributed attack surface, billions of connected devices embedded everywhere, in homes, hospitals, cities, industrial systems. When we talk about Internet of Things, we talk about cameras, voice assistants, routers, smart meters, connected car, medical devices. These are no longer peripheral technologies. They are embedded in daily life and increasingly integrated into critical services. So from a governance perspective, Internet of Things creates three major challenges. One, that is also treated in some of the regulations in Europe nowadays, is the fragmented global supply chains. What does it mean? IoT devices are built across complex global supply chains. So hardware may be manufactured in one country, firmware developed in another, cloud services hosted elsewhere, mobile hubs maintained by yet another entity. In a geopolitically tense environment, this creates both in compliance dilemmas, like questions are, who is accountable for vulnerabilities? Who ensures long-term patching? What happens when a vendor exits a market due to sanctions, or even worse, is end of product? Like, for example, what's happened to some of the vacuum cleaner in the last day, like, for example, Roomba just got busted. How do we assess embedded third-party components? Because unlike cloud services, many Internet of Things devices remain deployed for 5-10 years. When you have a camera in the underground, can be stay there like for 20 years, often without even an update. So governance frameworks struggle to address this long life cycle. Another point is security against sovereignty. Cybersecurity is increasingly combined with digital sovereignty. We see regulatory divergence emerging. For example, the EU Cybersecurity Act in Europe. We can talk about this later in more detail, but in few terms, means that any product with digital elements of needs that will be sold after 2027, from 2027, needs to be compliant with these regulations. It is about cybersecurity of this digital element. This is in Europe. Then in UK, we have the PSTI Act, so the Product Security and Telecommunication Infrastructure Act. In US, you have the US Federal IoT Security Requirements. In Japan, you have the Japanese JCSTAR, the Chinese Cybersecurity Data Localization Regimes. So while these frameworks aim to raise similar security standards, geopolitical tensions risk fragmenting the global IT market into regulatory blocks. Something that is compliant with the regulation in Japan, it's not compliant with similar regulation in Europe. And the results may be increased compliance costs. The same manufacturer needs to be compliant to 4 or 5 different regulations. This is okay for for big manufacturers, but maybe a problem for small manufacturers. Reduced interoperability, barriers to coordinate vulnerability disclosure, and limited cross-border incident response collaboration. Yet, IoT threats do not respect borders. So botnets, a good example of a botnet, a famous botnet is Mirai attack in 2016. built from insecure consumer devices have already been used in cross-border attacks. So governance must therefore balance sovereignty with coordination. And then there is another aspect that we couldn't think about since 3 years ago. It is the AI amplifier. AI, in this very moment, is not just driving innovation. It's a powerful tool for hackers. It is reshaping the threat landscape. So this tool, not only LLM, but AI in general, can automate vulnerability disclosure, large-scale exploitation, can enable high adaptive phishing and social engineering. At the same time, IoT devices, as we may know them today, cannot be the same in a few years. They are already incorporate AI locally. Alexa already announced it, so Amazon already announced it, that AI LLM will be incorporated in Alexa. We have edge AI camera sensors and autonomous systems, and this raises new governance questions. One is, how do we audit AI models in embedded devices? Who is responsible for adversarial robustness? What are the privacy implications of on-device inference combined with cloud telemetry? Not all AI work locally. So cybersecurity governance must now account not just for the software flaws, but for model vulnerabilities and, most important, data pipelines, so privacy. Another important problem of the Internet of Things is the fact that the infrastructure is invisible. What does it mean? From my work in IT security testing, so for the ones that are not familiar with my work, here at University College London, we have built one of the most Internet of Things tested in the world, in which we have the capability of testing privacy and security of any kind of consumer Internet of Things devices, but also industrial and medical. And from the works that we have seen, that we started in 2018, our one pattern is very clear. Many vulnerabilities do not stem from sophisticated attacks. They stem from very stupid errors of implementation of the devices. So very poor configuration, hard-coded credentials. Like, you cannot imagine how many times we have seen the devices be set as password and username as admin, or admin and password. Out of the libraries, insecure update mechanisms. These are basically governance failures, not technical problems. So governance frameworks must therefore incentivize secure by design development. And in Europe, this is the goal with the Cybersecurity intact. Mandate vulnerability disclosure process. An example, we tested reply attacks on 80 devices that we have in the lab. We disclosed this vulnerability. We saw that half of them were vulnerable to reply attacks. We disclosed this vulnerability to the manufacturer before publishing the paper. Only 2 of over 40 devices replied to our disclosure and created a updates that then solve the vulnerability to the millions of, for example, smart bulb, for which this vulnerability was the problem. So if there is no mandate for vulnerability disclosure, unfortunately, every time a vulnerability is found, there will be no consequences. So luckily in Europe, this is also mandated, but will be mandated by the Cybersecurity. But how these vulnerabilities are coordinated, with vulnerability disclosure are coordinated, how it's possible to disclose them without allocating any potential problems to the Internet of Things devices user is still under study. And then an important point is we need support and enforcement for regulations. Regulations alone is not enough. We need independent testing, automated testing, and benchmarking for these devices. Otherwise, everything will become like these regulations will become like GDPR, for which we have the regulations. We have 40 pages of privacy policies. No one checked them. And then the devices, in any case, do whatever they want. And there is no way to enforce regulations. So we need to change this enforcement. So to conclude, what are the lessons that we can draw? First of all, cybersecurity governance must move from reactive compliance to something that is measurable. So security claims should be testable and verifiable. Second, we need structured collaborations between regulators, researchers, industry, law enforcement, lawyers, especially for Internet of Things related crime. Third, governance must consider the entire life cycle of the device, from design to deployment, maintenance, decommissioning. They should be continuously monitoring. And finally, geopolitical tensions make, unfortunately, this coordination harder, but also more necessary. So fragmentation may offer short-term strategic autonomy, but long-term resilience require interoperability between countries, shared vulnerability intelligence, and cross-border cooperation. Thank you a lot.